Hi guys, welcome to the Fort Daily Demos. This is going to be a kind of an extension of the last video I just created, which is helping you with developing believable staircases in perspective. So this image that I have for you right here is just a drawing I've done in the past. I'm going to do a little variation of it, but we're going to do the same idea. This is a one-point perspective application now. So the previous video was in two-point perspective. And we're going to take the exact same rules, same principles and concepts, and apply it to this one-point scenario. In this case, we have a staircase rising up on the left-hand side of our scene. We're going up to, I'm going to slide this down. We're going up to, you can see the slope vanishing point up above our central one-point vanishing point. So I'm going to go ahead and do this same scenario, and also our division system is articulated here as well. So again, watch the other video, the two-point perspective. That's kind of part one. Maybe I'll label them as part one or part two or something sequential in that way. But regardless, I'm going to do this exact same staircase, or more or less the same staircase. But I'm going to start with this drawing now. Move that off to the side. And in this scene, I'm going to make the loft right there where that blue line is, the second floor anyway. And I'm going to bring the staircase down on the right-hand side. I could bring it out towards us in the foreground over here, but for the demonstration purposes, the mechanics get really flat here with the vanishing point. It's very hard to see it. So for demonstration purposes, it'll be a lot clearer to build the staircase off on this right wall over here. All right. Go ahead and remember now, we went through some math. We're going to do some different math this time. Last time we used an 11-foot floor-to-floor height from the first floor to the second floor. And this time I'm just going to switch up the numbers a little bit just so you can see how you apply the numbers again. Okay? So remember our terminology. Where's my, put a little blank sheet of paper behind here so you can see it. Remember our terminology, things you need to know, staircase terms, rough dimensions of the stair tread and stair rise. We need our sloped planes in perspective, that concept and that principle, and division system in perspective. Again, tread is approximately 10 to 11 inches. For our perspective drawing purposes, we don't have to be spot on perfect, but this is, again, you can modify those numbers as you need. What you don't want is a stair tread that is 6 inches in length. That's way too short, obviously. You may have some cultural differences. Some parts of the world, people are a bit shorter, have smaller feet, and are more comfortable with a smaller tread. That's perfectly fine. Maybe they use the low end of this spectrum of 10 inches, or you have a very steep area to work with. You may need to use a shorter stair tread. Now, in America, we may not get away with that in terms of codes and things like that. So you're gonna have to watch your codes and all that business. But again, for mechanics and for getting the ball rolling, some rough numbers will help you out, okay? Our rise, which is the height from step to step, the rise we typically use anywhere from 7 to 8.5 inches. Again, depending on if it's a commercial, public project, or a residence, we'll modify those numbers, right? And then we have overall run, and we have overall height, right? The floor-to-floor height. So in this scenario, let's modify the numbers a little bit. It's the same concepts, same principles. We're just going to apply it slightly differently. Why don't I use this sheet of paper? Save some paper today. All right, so this time, let's go back to our perspective here. Let's take a look at what we've got. I have a 5-foot eye level. Horizon line is at 5 feet. 0 is our floor here. This is 1, 2, 3, 4, and 5 feet. 6, 7, 8, 9, 10, 11. So this is a 12-foot ceiling. We could run the stairs all the way to the 12-foot ceiling height, or to the 12-foot floor level height. It's currently a ceiling, but that could be the second floor. And then we would have some structure down below, and that would be our ceiling down below. So make some choices. Again, you can push the numbers around a little bit. I'm going to make this more of a urban loft, meaning that maybe I don't have quite as much ceiling height as in the other drawing that I did. So maybe I need to have a lower ceiling. So let's go with 5, 6. Let's do a really low ceiling over the kitchen. Let's call this a kitchen in the back. And let's make it 7.5 feet. And then I'm going to put a loft in here, and let's make that a floor thickness of about 18 inches. So my loft is going to be here. My loft height is going to be here. I'm going to get rid of that line as I build the drawing later, or I push the ceiling height up. Okay, so this is where my ceiling is going to be. That is now 5, 6, 7.5 feet. My floor level, 8, 9 feet. Okay, hopefully you can see that in the drawing. So I'm going to put my floor level there, and I'm going to carry that floor level across. It's going to be right there. And I'm going to put my staircase coming out here in the foreground. So we're going to do some of that math again. Let's bring back our, blank that out a little bit. Let's bring that math back. It's going to be this kind of structure, this analysis. So we're going 9 feet now. I'm going to switch to a Sharpie so you can see it. Let me get a calculator. We have a 9-foot rise that we're going to go, a total rise. And let me get my calculator. I should have had this prepared. Sorry about that. Okay, so 9 feet. If you can do the math in your head, that's great. Sometimes I get a little bit trying to talk and think and do all these things at the same time. I don't think great. 9 times 12. I should know those timetables. Okay, so 9 times 12 inches per foot, right? Okay, 9 feet times 12 inches per foot equals 108 inches. Feels like this pen is dried up. 108 inches. That's my total rise. In other words, from floor to floor. Okay, so second floor. First, okay? Or the loft, however you want to call it. And so I have 108 inches there. And now I can take 108 inches and I can divide that by what do I think I want to use for my stair tread length, right? My stair tread length. Do I want to use 10 inches, make it shorter and steeper, or do I want to make it closer to 11 inches and a little bit slower and longer? Okay, so think about some of those ratios. If you're dealing with the elderly, you may need to use much shorter rises, because it's a little bit strenuous or difficult on knee joints and things like that to step a higher step. If you're dealing with a culture that has typically shorter people, closer to 5 feet, 5'2" as an average height, then maybe you're going to use lower rise heights, okay? So in this case, let's do 108 inch vertical, total vertical. Let's divide that by, let's say 7 inches, okay? Let's use 7 inches in this case. Divided by 7. Again, if you can do that math in your head, great. Otherwise, pull out a calculator. It's all good. 108 divided by 7 is equal to 15.43. Again, we can't have 4/10 of a step, so just round your 15 up or down. If I round the number down, then what I'm doing is adding a little bit of height to the 7-inch rise. And if I round it up to 16, then my step height actually goes down a little bit. I'm just going to round it to 15. So now I've got 15 steps. And what I need to do is make a determination about how much total run length that's going to require across the floor, right? So I know how far out to come in my drawing. So let's use a tread length of 10 inches. We're using really short numbers here. That's okay. So let's use 10 inches, so 15 times 10 inches, that's again our tread length. Gives me obviously 150 inches, that one's an easy one to do off the top of my head. And then divide that by 12 inches, right, per foot, 12 inches per foot. And we get 12 equals 12.5. Now this is 12.5 feet, so 12.5 feet is 12 feet 6 inches, okay? You guys around the world who are using metric, I totally understand. Maybe one of these days I'll do a metric drawing and using millimeters or centimeters. But obviously this is using the imperial system, using division, quarters, inches, halves, all that stuff. So there's our math. We have 12-foot, 6-inch run. We're going 9 foot rise. So going back to my drawing here, let's apply these numbers. I'll try to leave this in the screen so you can see it. We're going 9 feet on our rise, and we're going to go 12 feet 6 inches run length, which means if I count from the back of my grid here, I can go 1, that's 0 at the wall, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I can eyeball 12 feet 6 right there. Okay? So that's where I'm going to get my staircase started. And the first thing I like to do is go ahead and strike, where's my blue pencil? There it is. First thing I like to do is strike in the first step. I know that's where I want to put my first step. That's an easy way to start to think about it. I also know that the first step is, so this is the floor. First step is going to come out this way. Again, we need to think about the width of our staircase. If it's a typical staircase width, it's about 36 to 42 inches. That would be, I believe, a minimum standard. It depends on, whether you're doing residential or commercial public work. Let's say this is a little loft. We could actually go even skinnier if it was an urban loft, perhaps. We'd have to see if that would pass codes or not. But let's just do 3 feet. So this is 1 foot, 2 feet, and 3 feet off of the wall. And as it turns out, look, you can see it's going to line right up with the back of that sofa right there. So that's a good place to start. Sounds good to me. So now, what I'm trying to do is create a slope that goes from this floor level right here, right? This floor level, or this landing area in front of the stairs, up to here. This is the loft level, and the ceiling is going to come across here, right? So I can build that in later. So we're trying to get from this floor level, that's our second floor, from here to there. I don't have my stair heights at the moment, so what I'm going to do is I'm going to follow my grid back to the back wall, which is right there, or I could have also counted the grid. The staircase is going to own this zone right here and come down. I just don't know exactly where at the moment. Now remember, we need a vanishing point above our regular vanishing point, so somewhere along here is going to be the slope vanishing point, okay? Vertically off of our base vanishing point in this case. I don't know exactly where. We did calculate that we have 15 steps to take us from here to there in approximately 7-inch rises. Okay, so 15 steps. I'm going to use my division system to divide this length from here to here 15 times. So if I line up my architectural scale, wow, very, very close again. Wow, I've gotten lucky in 2 drawings now. It's not 100% perfect. Using an 1/8 inch scale along that vertical line, it comes up a little bit short. 15, where is that? Oh, I misread the scale. 16, 17, 18. All right, so what I'm going to do is over here, out of the way, off to the side, I'm just going to strike a line at an angle. This is my 0, 0 in the back of the room, so I'm lining up the architectural scale with that 0. All right, and I need 15 steps. There was 16 right there, so there's 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Now, I encourage you to make those marks as small and little and light as possible so that they practically disappear in your drawing later on. You don't need them after you use this system. All right, so the only reason I draw them as dark as I do is just literally for the video demonstration purpose. So what I'm doing is lining up this triangle. I'm bridging from 15 here to 15 where I'm trying to get to. Just create a little line right there, okay? That's the line alignment of the triangle that you want. I'm taking the second triangle and blocking against this triangle. Some old school triangle magic. And then I'm just literally translating 14 over to 14. And if you have an adjustable triangle, use an adjustable triangle. It's a little bit easier and faster. That was 13, 12. I may have miscounted a step here. We'll see. Okay. I'm just transposing the even divisions over here on the left at that weird angle over to the vertical edge. I get asked all the time, what angle is that supposed to be at? It doesn't matter. It's just whatever's a nice, comfortable, gives you nice, easy, comfortable geometry that you can map across there very easily. You notice I draw a line that strikes through the vertical edge. It gives me a nice, clean, crisp intersection. It's way more precise than trying to draw a little mark. The intersection of two lines is more precise than a little point on there. All right, so now my vertical edge is divided evenly, 15 units into 15 even increments. I no longer need this over here, so draw that stuff light or so it's not obscuring your vision. What I can do now, though, is I can take this first step height. That's the first step height. I need to get it out here in the foreground. So go off the vanishing point, through that first increment, out here in the foreground. I'm not going to draw the whole thing. I'm going to switch back to my blue pencil. That's the first stair tread. Remember, I'm locating it on this side of the staircase because this is in the same vertical plane. This is in the same vertical plane over here. So that I can trust. You cannot take the dimensions from over here or the increments from over here over to this wall. You're switching or twisting space when you do that, okay? So you have to practice controlling those relationships. I now have the first step height here in the foreground. I have where I'm trying to get to. So I'm going to draw a line that connects those 2 points, just like that. That's the slope of the staircase, and that's the slope vanishing point on the vertical line above the vanishing point. I now can take this first step horizontally over to the wall, and I now have confirming geometry. This is the loft, this is the first step. If I draw a line between those two, it's going to intersect to the diagonal slope vanishing point. So, oops, I will go ahead and make a little note on my sheet. This is our slope VP. Right there, okay? I don't normally draw dots, and I would encourage you not to either. I like to have just simple cross intersections. It's far more precise than a dot that gets really blurry and fuzzy and sloppy, okay? I now have my slope. I'm also going to build, remember our staircase geometry from the previous video? I like to have a guideline for the underside of the steps, in other words, across here. And again, we don't have a definition for, I've yet to find a definition for what that's called. So if anybody knows what that's called, please weigh in, let me know. I've looked everywhere. We do have noses, the nose of the steps. So far my guideline here is the nose of the steps, across the nose. These are called noses. But we don't have a definition for those. So I'm going to use a red line for the underside. And you could do all this in graphite. It doesn't matter what your colors are, but colors definitely help early on in the beginning when you're first trying to do this stuff. So there's the slope of the underside of the step. I'll do that on the other side as well, the edge against the wall. I don't need to draw it all the way, it's fine. If you notice, my mechanics have been pretty good. It goes right through the very last step, okay? It goes right through that last step, which is perfect. That's our 14th step in this case. So I'm going to go back to my blue pencil. I've got a lot of what I need at the moment. I'm going to just go ahead and get set up right here, vanishing point. And while I'm in position, I'm just going to go from the back vertical edge. Forget about that diagonal. That diagonal will throw you off. It's not relevant now. It's no longer needed at all. I can come back and erase it. Vanishing point through the vertical intersection. Get my hand out of the way. Through the vertical intersection, step number 2. Transpose that horizontally out here in space on the front side of the staircase, okay? Again, don't switch it to the wall yet. Go through step number 3, back there, a little horizontal. I'm just drawing my horizontal between the red and the blue lines. Don't be intimidated by the piece of furniture that's in the foreground. Don't worry about the design of the piece of furniture yet. All those things you can block in later. And I just work my way up across each of the intersections. Again, when I get to the horizon line, the geometry starts getting really flat. Very, very difficult to build one step at a time and do a decent job at it, because you're going to lose your geometry right there, and then you're going to fake it, and then your stairs are going to wind up wandering, and it's going to look terrible. I've seen it over and over and over. So my very last step, number 14, is right there. And then actually the very last step is the floor level up above, okay? I'm going to go ahead and zoom in here a little bit so you can see the drawing a little bit closer. Okay? So you got those mechanics. So now that we have all the treads, each of these blue lines is parallel to the floor, parallel to the horizon line. We understand that conceptually from perspective. Once I have that, I can draw the vertical right there from the blue line to the red line. If there's any little error in where that should all intersect, if you've done a really good job with your mechanics, it should be pretty close. If it's off a little bit, don't stress out about it. Just simply balance it out. Find an average intersection, like right there it's off a little bit. I'm just averaging where it intersects there and there, right there and there. Just find a little averaging out, okay? What's great about this system is that you are averaging out little errors and flaws that emerge because, hey, we're human, we're not perfect, we're not a computer, right? So, but I have very nice, believable increments and all the mechanics falling into place. From here, all of my noses, stair noses, and whatever that little other definition is there, those are all just simply going to be parallel to each other and parallel to the horizon line. This is a one-point system. Whoops, I drew that one a little bit long, no big deal. I only need to go to the red line on those inside edges, inside cuts. This is where on like colonial, kind of old colonial architecture and things, you'd have like a staircase runner rug, and then there's this little rod that they would like put across the staircase, and it holds the carpet back against that inside corner, keep it from slipping and people getting hurt. So if you know what the name of that rod is, I guess we could call it that. I don't know. Maybe I should do some research. Some more research. I hunted around, but nobody seems to know. Anyway, I've even asked a contractor friend, and he didn't have any idea either. So anyway, as we get over here, now we're above the horizon line, and the noses are the only part that I really need to draw. The nose will come over to the blue line against the wall. Like that. And with a little practice, you can knock out a staircase in, I don't know, 5 minutes or so, I think, or less. You know, I'm doing a lot of explaining and slowing down on the mechanics and the math just to walk you through it, but it's actually quite easy. Once you get the hang of it, it's the same system over and over. I love redundant systems for my students because you get more practice and you just apply it in different ways. Don't worry about that little mistake right there. It's all underlay. And then the stair tread going back here should all connect right there. Goes back to the vanishing point. Again, center vanishing point. Again, if you have little flaws in how everything intersects, just kind of balance out the flaws. Nobody's ever going to care and know as long as your proportions and your foreshortening is tight all the way up. And that's it. By this point, we can barely even see that. We can barely see that. Barely see it. Our horizon line's right there. So that's our staircase. And at this point, clearly we only have a loft level that's 1, 2, 3 feet. So if somebody were to try to stand up there, they're going to hit their head on the steps. They're going to need to crouch or kneel. But you could certainly have like a loft style bed up there. You know, I'll just kind of sketch in a bed mattress. Did I even sketch that the correct length? Maybe 1, 2, 3, 4, 5, 6. I drew it a little bit long. So maybe there's a mattress there, 6 feet, maybe 6.5 feet or 7 feet. You could have like a loft style bed up there. But if you really want to have a taller ceiling, just move your ceiling height up. So add 3 or 4 or 5, 6 feet up here, and then come back from your vanishing point, and now your ceiling plane is up higher. And I push the wall back as well. Push the wall back as you see fit. All right. This is really about the staircase mechanics. We also have, at this point, we do have 3 feet in vertical height. But if you didn't have this for your handrail, so if I start to put a handrail here, I know that it's going to be 3 feet here at the ceiling, or up at this front plane, this wall plane. But if I didn't have that, I could also count steps. I could say, well, based on our 7-inch increment, again, we went with a 7-inch increment for our stair height. So 7 will go into 36 approximately 5 times with a little bit left over, right? 7 times 5 is 35. Okay? So if I just count 5 steps here, 1, 2, 3, 4, 5, I know that that is approximately 35 inches, and I can just add a little bit to that. So if I take that dimension plus a little bit, I know that 36 inches is about here in the foreground. So I'm going to take the front step up to that little line that I just drew. That would be the edge of glass, and that would be 36 inches. I can take that to the slope vanishing point, up to the top of the staircase, and that's where my 36-inch or approximately 36-inch handrail is up above. You notice the mechanics doesn't come out exactly the same because I just eyeballed it down below. That's okay. I'm going to go with this. So there's my glass up above. Again, just for the demo purposes, a little bit of glare effect across that. Just so you can see, I'm starting to think about this as glass up here. Certainly you can design your handrails however you like, or you can have a balcony up here with more geometry and detail. This video, I don't have time to do all that, so I'm just giving you the basic structure and mechanics. If we want to start to add rounding to the staircases, we can. If we want these to be floating steps, then I can just simply add a little thickness here, and I start to evolve and emerge the glass edge thickness. I'll just do a couple of these. So now I've got floating stair treads. I always say draw like the glare for the glass edges. It's a way easier approach. You will have a little bit of transparency there. So you can kind of start, I always say start with when you're doing glass, start with the edge dynamics. So there's an edge dynamic here. And back off of trying to draw the glass plane. You don't need to focus on that as much. Okay? So there's some floating treads. We would certainly need some kind of structure underneath that. I'll go ahead and start to put every third step, I'll put like a little break between the glass. 1, 2, 3. That helps you start to see the handrail. 1, 2, 3. And again, you can see we've just done the same mechanics. 1, 2, 3. And we've got like an odd leftover 1, 2 steps at the end. Not the most elegant solution right there, but I'll live with it for this demo. Don't forget the underside of the glass, unless it's set into the stairs or something like that, or it could be mounted to the outside of the steps. All those are your glass structure mechanics, and getting to better understand how things are fabricated, how something like this would be fabricated. Coming back here to my floor thickness, I don't want to leave you stranded. I'm going to go ahead and build some vertical thickness. Let me switch to my graphite pencil so maybe you can see this. So now my floor height, my loft height, again I said 18 inches, so it's 18 inches over to here. Remember, conceptually I'm moving that wall back. So this is now a vertical plane in the same plane as that glass up above. Right? And if I want to give the illusion of some space back here, I just continue this edge towards the vanishing point, and I'm just going to eyeball moving the wall back in space, just so you guys can see the evolution. So I've literally just moved that wall backward back here. I'll go ahead and finish this out underneath the stairs right there. So now this is my ceiling plane underneath the loft. You can see I've pushed the wall back, and I could slow down and figure out how many feet I actually moved that if I need to, or if you need to. So the back plane is over here now, and it looks like I see the ceiling kind of cut across right there. Disappears behind the steps right there. I'm just shading this in for you, you guys at home. I would do a lot more construction work. This is where the vertical wall is. This is the horizontal plane of the floor now in the background. Maybe there's a kitchen back there, or I start to build an island. This is 1, 2, 3, 4, 5. Let's give the island a 3-foot space here, and come over this way, and it's 1, 2, 3, 4, 5. Let's make it 6 feet long, and it is 1, 2, 3 feet towards us, and I'm pushing it right here in the foreground or in front of that wall. Come back over to the wall. I count up the modules, 1, 2, and 3. And 3 feet on the wall is here, so that means if this is a 3-foot island, this is the front edge of the front plane of the island, and then that front plane goes back towards the vanishing point in that direction, and in that direction. I'm just building a box now so I can locate the back edge of the island. So there's the top plane of the island, and this is the vertical plane of the island. And I could start to build bar stools or something like that around it and detail the drawing. Okay, so we're at about a half hour into this drawing. The staircase should only take 10 or 15 minutes when you get the hang of it. Again, it's about slope vanishing points. Let me zoom out again so you can see that. Slope vanishing points for the slope of your staircase, and understanding the division system there as well. Okay, you nail those 2 things, and you're off to a pretty good start, I think. Hope that helps. Feel free to write me. Let me know any requests, any suggestions you have for areas that you'd like to see some demos, and I'd be happy to produce them for you. Have a great day. Bye.